of Artemis 1.
Artemis 1 was incredible. It was an iconic mission.
I was able to watch the launch of Artemis 1, and I'll never forget, I just turned into a small child, and I just was screaming at the rocket for about 30 seconds.
That is our generation, the Artemis generation, that defines the starting point of our exploration future.
Next thing is getting ready to fly the crew on Artemis 2.
This mission paves the way for sustained missions on the moon and then Mars.
We've got spaceflight vehicles that are down at the Kennedy Space Center that are being built and integrated. We've got components of a rocket that are being assembled.
We have international partners. We have commercial partners and industry partners.
We've got the designs ready to go, how we're building up the operations.
It's real. The team is ready to go.
4 names, 4 explorers, answering the call to once more rocket away from Earth and chart a course around the moon.
This is the mission of Artemis 2.
Never before had man traveled so far, so fast, or looked so closely upon another celestial body.
It's one small step for man, one giant leap for mankind.
Apollo was so amazing because we didn't know we could do it. The Apollo generation showed what was possible.
For me personally, I think it's an important endeavor to return to the moon. And as we look towards Mars, the moon is going to be an important staging area for us to learn quite a bit. The longest we were ever on the moon as humans was 72 hours. We have a lot to learn yet.
And as we leave the moon in Taurus Littoral, we leave as we came, and God willing, as we shall return, with peace and in hope for all mankind.
The Artemis campaign is really a set of test flights. We haven't been to the moon in over 50 years, and so there's a lot of new systems that we need to test out. We're going to a new part of the moon, the South Pole, that we've never been to before with crew. The Artemis 2 mission is going to take the next step in our flight test campaign. We're going to focus on what are the new systems that we need to test out so that we can fly crew to the moon and safely bring them back home. That really sets us up for our big goal, which is the return of human crew to the surface of the moon.
It's so important what we learn in that mission to the moon because it instructs us on how we're going to get to Mars. This is a generation-defining effort.
My name's Jeff Radigan. I'm the lead flight director for Artemis 2. Here in Mission Control, I direct the operations of the spacecraft and communicate with the crew on board in order to have a successful mission of a first mission back to lunar space in over 50 years. We want to get back out to lunar space. We want to fly around the moon. And so to be a part of that is just very meaningful to me. It's something I get excited about when I wake up in the morning. It really is the next step in space exploration.
GC, go. Guidance, go. FIDO, go. Prop, go. GNC, go. Max,
this room has a lot of historical significance. We originally flew the space shuttle out of here, and we're looking forward to flying Artemis 2 out of this room here in the not too distant future.
Once the vehicle clears the tower, control of the spacecraft is handed over to Mission Control Houston. At that point, the team in Mission Control, led by the Ascent Flight Director, will take over. It's a very distributed team. Think of it as a big pyramid. At the top of it sits the flight director, but around him are specialists in every system on Orion. They'll have teams in the front room that are working with the flight director. They'll have teams in the back room that are supporting the front room operators to make sure that they're specialists in all of their systems, just in case we have a problem that we haven't seen. And by the way, in my 20 years of human spaceflight experience, I guarantee you we're going to have a problem that we haven't seen.
My name is Natasha Peak. I'm a flight dynamics officer for Artemis 2. We are trajectory specialists when it comes to Orion. Really, my job is to know where your spaceship is and where it's going. And if we need to come home for some reason, come home early, or we get off track, our job is to figure out how to do that. This mission is fundamentally different from a mission you might do in low Earth orbit in a lot of ways, but one of them is that we're looking to rendezvous with the moon. Every minute you wait to launch, the moon is moving. So in order to rendezvous with it efficiently, we have to change the inclination of our orbit to make sure we line up with the moon. In a month, you get about 14 days of a launch period. Our team all hunkers down, and for every day, we look at the open and close of the window and come up with a trajectory end to end, from liftoff all the way through splashdown.
You know, I often talk about that launch ops is like a team sport. It's certainly you have to produce on game day, but that the preparation for a championship begins in the off season. We've made some significant upgrades since Artemis 1, and that includes not just the software that you see out here running on the consoles, but it's also in our model and simulation environment. The big difference between Artemis 1 and Artemis 2 is, of course, the crew. And it's the systems, the new systems that are specifically in place to support a crewed flight. And so we have new launch commit criteria, we have changes to our procedures, changes to our timelines, and we want to make sure that we've gone through those time and time again so that when launch day rolls around, we're ready for anything that the hardware may throw at us.
We woke up this morning, went through medical checks, had breakfast as a crew while Charlie and her team were getting the simulated vehicle ready for launch day. We got in our crew transfer vehicles, our CTVs, we came out to the pad. We went up 2 elevators to the 274-foot level, and we met there, our White Room closeout team. So it was a great end-to-end run-through of what we will do when we get on this vehicle and head to the moon.
There are no shortcuts. I mean, you have to do it all because on launch day, that is game day. And it is in all of our work together that gets us to a successful T0 and a safe and successful mission.
Hey, Sam. What's going on? Not much. Long time no see. Time no see.
The seriousness of what it takes to take the risk with humans in and of itself creates enough of a pressure for the entire organization, enough of a concern, enough of a sense of rigor. Everything goes up a notch.
We have to have an atmosphere to breathe, a temperature to be able to control, to be able to take out the carbon dioxide and the humidity that's in the air, feed the crew, deal with a small environment, proving that we can fly by the moon and come back and have a safe reentry.
There's an extra element when you have humans on board, the nuances by which the system operates, the understanding of what it is to live in this crew module that we have. Artemis 2 is also another flight test of the other systems that are required to enable human space exploration. That is life support system, that is displays, that is the controllers, the stick that you need to fly a spacecraft. All those pieces were not part of Artemis 1, but are really key for Artemis 2, and the crew will need that capability to go forward to do human space exploration.
When you go to the moon, you're 250,000 miles away, and there's no choice. It takes time to get home. Everything we check, everything we try and make sure we understand, we double, we triple, we quadruple check because we want to make sure we get it right.
The mission will prove the Orion spacecraft is ready to keep astronauts alive in deep space and allow the crew and ground teams to practice operations essential to the success of future missions.
This top portion is the crew module. It's the pressurized area where the crew sits. The bottom portion here, with the solar arrays and the engines, primary engines, is what's called the service module.
The European Service Module, or ESM, will provide electricity, water and air to NASA's Orion crew capsule, as well as maintaining temperature for life support.
It's been a fabulous partnership with our ESA partners. The agency made a decision a long time ago that we want to do lunar exploration as a global partnership.
Now that we're having crew, that's the new element for Artemis 2 and onwards. We will really go into the testing of the life support systems and try to figure out how is that behaving with the astronaut in the loop, how is the CO2 scrubbing working on the crew module side, how are we providing the oxygen to the astronauts and the water.
That environmental control system is so complicated. It's a series of chemical and mechanical and electrical engineering problems that all have to come together. That spacecraft has to basically be a mini Earth. And that Earth is basically driven by the elements of that life support system.
We also have crew interfaces with the crew piloting the vehicle. Artemis 1 was uncrewed, and so we're going to go do a checkout right at the beginning of the mission while we're in an Earth orbit to be able to ensure that the crew is able to successfully pilot the vehicle.
We're not just testing the systems in Orion. One of the key things we really want to do is We're going to do science.
When we think about Artemis II science, there are really three big areas that we're studying. One is understanding the space environment. The second is understanding how that environment interacts with life and humans and the systems. And then the third is looking at the moon itself from a vantage point where humans haven't looked for over 50 years.
They're going to be describing what they see. They'll see things that human beings have never seen before. They'll be describing, observing, and documenting what they see for the scientists back home.
They've done a significant amount of training in the field here on Earth, learning about geology and planetary scale processes. They'll be looking for the evidence of those processes from orbit and describing to us anything unique that we maybe haven't been able to really sense with orbiters and robotic measurements.
We're also going to do human research on the crew members themselves. We haven't had data sets for over 50 years on how the physiology of the crew themselves adapt to the radiation environment, to the microgravity environment so far away from Earth.
When you think about Artemis II, we've never had humans get